Oxweld gas apparatus is preferred by most steel producers, heavy scrap processors, and foundry and forge shop operators where there are requirements for heavy-duty gas cutting because of its dependable, high-performance operation and long service life. And Oxweld has been used by many of these demanding customers for over 90 years. Previously manufactured by the Lindy division of Union Carbide Corporation and L-Tec Welding and Cutting Systems, Oxweld is now an important product line of ESAB Welding and Cutting Products, the largest manufacturer of welding equipment and consumables in the world. In 1997, ESAB added a new heavy-duty hand-cutting torch to its Oxweld line, a torch that represented a radical departure from traditional cutting torch designs. Called the Pm Gst for post-mix gas-saving torch, this revolutionary torch offers a number of operating advantages compared to conventional torch designs. Advantages such as safer operation, gas savings, less smoke and fumes, longer consumable life, deeper cut penetration, and it's more forgiving and easier to use. In conventional torches such as this, fuel and oxygen are brought together and mixed within the body of the torch or within the tip itself before entering the atmosphere where they are ignited. We'll refer to this design as premix. Premix tips have a series of preheat holes or slots surrounding the central cutting oxygen orifice. When the preheat gases exit these holes, fuel and oxygen are already mixed. Premix preheat flames are cone-shaped and cling tightly to the front face of the tip, as can be seen here. Tips are generally held 1 inch or less above the workpiece, as shown. A flashback is perhaps the most serious incident that can happen to a premix torch. A flashback is caused when the preheat flames burn back through the preheat holes to the point within the torch where the gases are mixed. A flashback can be induced by a number of factors, including improper torch settings, faulty equipment, or operator error. A flashback is recognized by a loud report, accompanied by the disappearance of the preheat flames and a squealing sound signifying that the flame is continuing to burn inside the torch. If permitted to continue burning inside the torch, even if for only a few seconds, the flame will likely melt through the sidewall of the torch, destroying it and possibly causing injury to the operator. If the operator is trained to recognize when a flashback has occurred and taught to quickly shut off the gases, damage and injury can usually be minimized. Most operators have experienced a flashback. Post-mix torches, on the other hand, keep fuel and oxygen completely separate until after they leave the cutting tip, where they are permitted to mix and are ignited, hence the name post-mix. Pm Gst tips have an entirely different preheat design than premix tips. The central cutting oxygen orifice is surrounded by 2 concentric rings of preheat gas ports. The inner ports are for fuel gas, and the outer are for preheat oxygen. A preheat oxygen curtain is also provided through the annulus formed by the OD of the tip and the ID of the tip retaining nut. Since the fuel and oxygen are completely separate until after they reach the atmosphere, it is virtually impossible for a flashback to occur. Remembering that fire can only be sustained where fuel and oxygen are both present, the flame front cannot burn back inside the torch where there is no oxygen. Pm Gst is a safe torch to use because the possibility of a flashback and subsequent damage or injury is remote, even with defective equipment, incorrect settings, or operator abuse. Post-mix preheats do not form the cone-shaped flames which are characteristic of premix preheats. Instead, they are bushy and turbulent because the gases have not completely mixed when they leave the cutting tip. This lack of cone-shaped flames reduces intensity, making it unsuitable for piercing plate. When cutting oxygen is introduced, however, the preheat gases are drawn in, forming an extremely intense flame boundary around the circumference of the cutting stream. This flame reaches its maximum temperature at a distance approximately 5 inches from the end of the tip retaining nut. When using the Pm Gst for cutting, an edge start is required. To initiate the cut, the torch is held approximately 5 inches above the work, with the cutting oxygen flowing and its leading edge positioned at the corner of the material. A riding skid is available for some torch models to maintain the proper height during preheating and cutting. Perhaps the most unique feature of the Pm Gst torch is its standby or pilot operating mode. Post-mix operation provides the opportunity to adjust preheat gases to extremely low levels without adverse consequences. This standby mode of operation has been used for some time on post-mix machine torches to conserve preheat oxygen and fuel when the torch is not actually cutting. Special solenoid valving is used to reduce flows during idle times. This technique is dangerous with premix torches because attempts to restrict flow are likely to cause the flames to overheat the tip and flash back the torch. Pm Gst provides this pilot mode through the use of a special cutting valve design. The design consists of 2 valves in parallel, operated by a single cutting lever. One valve operates cutting oxygen, the other preheat. When the lever is not depressed, cutting oxygen is off and the preheat is in pilot mode. As the lever is depressed, gases are energized in the following sequence. First, the preheat switches to full flow, and second, the cutting oxygen is turned on. The torch is now ready to preheat for cutting. When the lever is released, the torch returns to pilot mode. The following procedure is used to light and adjust the torch. 1. Set the fuel gas and oxygen regulators as described in the instructions. Be sure to use hose that is at least 3/8 inch inside diameter. 2. Open the fuel gas throttle valve all the way and use a striker to ignite the flame. The resulting flame should be small, orange in color, and very lazy. 3. Open the preheat oxygen throttle valve slowly until the preheat flame turns whitish and disappears inside the tip retaining nut. It should appear as a white flickering flame. Pilot adjustment is now complete. The Pm Gst's pilot mode can reduce preheat oxygen and fuel gas consumption significantly in those applications where torches are kept lit in the standby mode for extended periods of time. For example, continuous caster emergency cutoff torches are generally left running at full preheat flow so as to be immediately available in case of an emergency. These torches typically consume 200 cubic feet per hour of natural gas and 400 cubic feet per hour of preheat oxygen. In the pilot mode, a Pm Gst will consume approximately 4 cubic feet of natural gas and 30 cubic feet of preheat oxygen per hour of operation. This chart shows the savings which can be realized. Savings are based on a unit price of 0.4 cents per cubic foot for natural gas and 0.25 cents per cubic foot for oxygen, which are believed to be reasonable costs for heavy users. Total savings per year is based on the number of hours per day that the torch is in the standby mode, when assuming a total of 300 workdays per year. Using these assumptions, each 1 hour of standby per workday will save the user approximately $513 per year. In the case of emergency torches that are in the standby mode for more than 20 hours per day, the annual savings will be more than $10,000 per torch. Obviously, the standby mode can benefit more than just emergency torch users. Foundries, forge shops, scrapyards, and others can also benefit, since it is not uncommon for torches to be left burning during work breaks and while material is repositioned or moved into or out of an area. A single shift operation that generates 1 hour of standby per day will save $513, while a 3-shift operation that generates 1 hour of standby per shift will save $1,000 $539 during the year. Natural gas and propane are the most common gases used with Pm Gst. However, propylene and even MAP gas have been proven to work well. Standby savings with any of these gases should be greater because of higher unit costs. When conducting visible emission observation studies under production conditions, users have observed that the Pm Gst produces far less smoke and fumes when compared to pre-mixed torches. When simple carbon steel is being cut, opacity spikes were observed to be 20% or less. Obviously, the amount of smoke and fumes is greatly dependent on the type of material being cut. However, for a given type of material, Pm Gst should produce less. Just why Pm Gst produces less smoke and fumes is still somewhat of a mystery. But obviously the combustion characteristics of the post-mix flame modify the oxidation reaction, thereby producing less airborne material. Pm Gst's consumable parts last longer than pre-mixed torch parts for several important reasons. First, the 5-inch standoff during preheating and cutting keeps the front end of the torch cooler. Second, the operator is less likely to accidentally dip the tip into the molten steel. Third, it is more difficult for damaging spatter to find its way to the tip. And fourth, the torch cannot flash back even under the most adverse conditions, and flashback is a leading cause of equipment failure. Pm Gst is simple to use. Burners will find it more forgiving than pre-mixed torches, particularly in heavy material where technique and speed are far more critical. The Pm Gst's post-mix preheat delivers energy deep into the cut zone where it supports the cutting stream much more effectively, carrying the cut through heavy thicknesses with greater ease and speed, and with resulting superior cut face quality. This deep penetrating preheat makes the Pm Gst effective in cutting troublesome materials like gray iron and for dismembering strip coils. ESAB's introduction of the Oxweld Pm Gst provides steel producers, heavy scrap processors, foundry and forge shop operators, and other users of heavy gas-cutting equipment with an opportunity to improve their burning productivity while reducing many of the costs associated with traditional pre-mixed torches. Lower costs associated with less likelihood of operator injury, less equipment repair and replacement, lower costs for fuel and oxygen, less EPA concerns, and quicker operator training can now become a reality. Shouldn't you be giving this remarkable torch a try?